Hello everyone, this is Aditya and today we are to study collision in special theory of relativity, that is the objects which are moving close to the speed of light. But for that, please do like, share, subscribe my channel and be support video. Now let's start. So to understand this, we have taken a very simple case in which there are two identical masses which have identical rest masses as m naught, and in that the first object is moving towards the second object at 0.99 c, that is 99% the speed of light, where c is what? It is the speed of light in vacuum, that is c is equal to 3 into 10 to the power 8 meter per second, or if I write it precisely, then it is 299,792,458 meter per second, right? Okay. So it is given that this collision will be perfectly inelastic collision. Okay. So it means that these objects will stick together and then move, right? So we have to find the final velocity. What is the final velocity? Find the final velocity in this case. So let's see. Okay. So basically, there are two bodies of identical rest masses, of which one is moving towards the second object at the 99% the speed of light, and they both will collide, and the collision will be perfectly inelastic collision. That is the given problem. So let's see how we solve it. So in this we'll apply law of conservation of linear momentum, correct? Linear momentum. Okay, so far so good. Okay, so basically first of all, let's conserve the momentum. Basically, first of all, let's find the momentum before collision, right? So momentum before, it is the linear momentum before collision, right? Okay, so before that I need to tell you something. For the momentum expression, you know that P is equal to mv, right? This is for classical mechanics, but when we deal in relativity, then P becomes gamma times mv, right? Or m naught, where m naught is the rest mass, right? Where gamma is called the Lorentz factor. It is equal to, gamma is equal to 1 upon root 1 minus v square by c square. You all must have encountered it if you have studied relativity before, right? It is like every time used in relativity, right? So it will be P1 initial plus P2 initial, right? So what is the initial linear momentum of the second body? It will be 0 because it has no velocity. It is at rest, right? Okay. So it becomes gamma times m naught v, correct? Where v is 0.99 c, correct? Okay. So we will get some value, but we are not bothered about that right now. Okay. Now linear momentum after collision, right? Let's see, after collision. So it will be P1 final plus P2 final, right? Okay. Now just think, they both have stuck together and then they are moving, right? Now they are moving. Suppose at some velocity, let's assume this as v naught. Say it as v naught, okay? Now say this velocity as v, okay? So it has a rest mass m naught, it has a rest mass m naught. And since it collided with a very huge velocity, right? You can see 99% the speed of light, correct? So it means that this velocity should also be comparable to the speed of light, correct? Okay. So it means that whatever expression you are getting, you will again have to multiply it by some gamma, right? So if we are assuming velocity as v naught, so let's name this gamma as gamma naught, because it is with respect to the velocity v naught. So what is gamma naught? Gamma naught is equal to 1 upon 1 minus v naught square by c square, correct? Understood? Okay. So what will be the final momentum? It will be m naught plus m naught, the total mass, into the velocity times gamma, correct? Where gamma is with respect to this velocity now, right? Okay. So this is equal to 2 m naught v times gamma, right? Okay. Understood this expression? Okay. So we have got this expression and we have this expression. Now from law of conservation of linear momentum, they both must be equal, correct? So we'll have gamma naught m naught v naught is 2 m naught v into gamma. So m naught and m naught gets cancelled, correct? Yeah. So we get gamma naught is equal to, sorry, gamma naught into v naught divided by, or just say it like this. So we have gamma naught into v naught is equal to, divided 2 is equal to v gamma, right? So we have this expression. Now we have to solve this. So let's see how we'll solve it. So we had this expression, right? So now let's name this as this expression, this gamma naught into v naught, as some alpha. Let's say it as alpha, right? Okay. So alpha is equal to, because we know the value of v naught, we know the value of gamma naught simply, right? So we get what is v? We need to find that quantity, divided by 1 minus v square by c square, correct? Yeah. So now let's solve it. So we will have alpha square is equal to v square by c square minus uh, v square, and here we will have c square again, right? Correct? Yeah. So we will have alpha square c square minus alpha square v square is c square v square, and now you will get alpha square c square is equal to c square plus alpha square into v square. That is bit of maths which you need to understand. This simple algebra, nothing more. Okay. So it is just I rearranged this expression, then brought c in c square in numerator. So I got this expression. I brought this to LHS. Then I multiplied this expression. Then I brought alpha square v square to RHS. So I got c square v square plus alpha square v square. I took v square as common. So I got c square plus alpha square is equal to this expression. So from this I will get that v is equal to alpha c by root c square plus alpha square, correct? Now I need to evaluate this expression where alpha is equal to gamma naught v naught by 2, correct? Okay. So let's further simplify this expression. So we have alpha is equal to 1 upon root 1 minus v naught square by c square into v naught by 2, right? Now we have to substitute the value over here. So we'll get alpha is equal to 1 upon root 1 minus 0.99 square, c square and c square will get cancelled, into 0.99 c by 2. We got this expression, and now we need to evaluate this. So on solving this, you will get alpha as 3.5 times the speed of light. Now we have to substitute over here, and let's see what we get as the final answer. Let's see that. So we get v is equal to 3.5 c into c divided by the quantity c square plus 3.5 c whole square, correct? Now let's evaluate this expression. Let's see what we are getting. So first of all, let's simplify it. We will get 3.5 divided by the quantity root 1 plus 3.5 whole square times c. Now we have to evaluate this expression. So let's evaluate this and let's see what we'll get. So we will get v is equal to 0.96 c. So it means that the final velocity of both the bodies when they are stuck together and they are moving, it will be 0.96 the speed of light, and that's ridiculous, right? So it means that the velocity has decreased a bit. Can you all tell me what is the reason that why velocity has decreased? Well, tell me in the comment section. So that's it. So the final velocity will be 0.96 times the speed of light. Okay, so I hope that you learned something new from this video, and if you find anything wrong in this video and any concept wrong in this video, then please do let me know in the comment section. Bye bye, take care, and the comment section is always open for any discussions. And of course, I've given different IDs on which you can contact me. You can contact me on Instagram also, you can contact me on LinkedIn also, you can contact me on Facebook Messenger also, or any other platform on which I am available. I'll try to answer you all. Bye bye, take care.